and then he will take you through his presentation for next around 1 hour or 1 hour 15 minutes, and then we will have a brief question answer session. Whenever you feel asking like questions during his presentation, feel free to ask in the chat box, or I have just opened the WhatsApp group, so you can post your questions there. We will take all the questions at the end of the session. Okay, don't interrupt in between to the faculty, and please keep yourself on a mute mode so that Mr. Bhavik can concentrate on his presentation. Okay, so that's a request from my side. And before I go ahead, I would request you that you visit ISSE website, just get to know about ISSE activities, and what is a student chapter, where are the chapters located nearest to you. Maybe in your college itself, there is one chapter open. Okay, and for opening new student chapters, generally 30 plus members are required, and the student fees for the student members is just 500 rupees. So imagine if you go to a pizza shop, we just land up spending 600, 800 rupees on a pizza. So here you can get one membership, okay, and avail the benefits of joining their webinars, seminars, then getting the literature online as well as offline, and discounted rates. So now, to tell you about ISSE, ISSE Indian Society of Structural Engineers was formed 27 years back by like-minded people in our industry, and under the leadership of late Shri R.L. Nene sir. And this institute was basically formed to raise a voice against whatever odds go in the profession in the favor of structural engineers, and to raise a issue in front of municipal corporation, government bodies, have a representation in front of them. And after formation in last 27 years, ISSE had organized several workshops. There are 3,000 plus members available, and there is a quarterly journal published by ISSE. ISSE also organized so many site visits, like to Golden Pagoda was organized, then it was organized to this Statue of Unity, and there are several visits which are organized. Then ISSE celebrates its foundation day somewhere in month of January, and there are so many local chapters are available, so many student chapters are available. To introduce a few publications, I can show you. This is a publication on corrosion. Then this is a publication on shear walls. Then this is a publication on pile foundation. Then this is a publication on pre-engineered buildings. Then this is a publication on wind engineering, and then there are several other books and booklets which are available for guidelines. So you can go to ISSE website, actually go through, browse through this literature, and you can purchase the entire set for your college or your personal collection by paying something like 4,000 rupees or so, and include I think the courier charges will be extra. So this is all about ISSE. The website is www.issc.org.in. So please have a look into this. And there is also email ID, dedicated email ID of ISSE available. So please take a full benefit, especially students of this, feast of knowledge. Coming to this activity, somewhere in January, we were discussing in the board of committee members of ISSE that what to do for the students, and then there are some couple of guidelines which are going to come. Then there are some incubation activities going to be started for students. So this webinar suggestion was given by ISSE President Shri Vadalkar sir, and then it was promptly started and recognized, and I was identified to anchor this entire activity. So we started this activity. It's conducted on every fourth Saturday at 11 a.m. So these all lectures are free lectures, and eminent speakers come and share their thoughts for 1 hour. So students are basically should get a full benefit of these webinars. And the aim is not to do any kind of publicity about ISSE, neither any products, but the aim is that to introduce students about how the practice is done, and whatever you learn in college, how it is practiced. So this is how this activity was started. Now let me introduce our speaker today, Mr. Bhavik. Yeah, just a moment. I'll open up his brief introduction which he has sent to me.
Or do you want I can share in my screen?
No, no, I'll read out.
Okay.
Welcome to Mr. Bhavik Dhami on behalf of ISSE student chapters. And Mr. Bhavik is currently working as a specification engineer with FOSROC India Private Limited, and he has completed his graduation from in civil engineering from Mumbai University of Mumbai. He also holds a postgraduate degree in machine learning and data science. His keen interest is on chemicals and repairs retrofitting, and he has previously worked as a trainee engineer with RRC Ventures, then Sanrachna Structural Engineers Private Limited. He also has some experience on mechanical components like lifts and all with Go Easy Lift company. And for last 1 year or so, he has been working as a specification engineer with FOSROC, and he has a good knowledge of basics of chemicals as well as the implementation part of it. So he'll be sharing some nice case studies also in today's presentation. So keep yourself on mute and ask all the questions which you have in a chat box or in a WhatsApp group. So with this, I welcome Bhavik Dhamiji, and you can start your presentation.
Thank you, Vivek sir, for giving a good introduction about me. So, also IISC for providing me this platform. So, students, I will be starting the presentation today. As you know, my name is Bhavik Dhami. So, I will be proceeding further. So, basically, I reside in Mumbai only, and all the brief introduction already given by Vivek sir. So I thank him for the introduction part. So basically, I have 7 years of experience, seven plus years of experience in structural repair and retrofitting and restoration. So my whole, you can say the broader aspects, it is with the project management and execution. And currently, I'm working with, you can say specification part. So a techno commercial role is right now, and I have been experienced with you can say various kind of structures during my tenure with Sanrachna. So it's come as a, like a commercial, residential, institutional, infrastructure, and industrial. So all kind of project were undertaken by me during that tenure. It was around 5 years. So that's all about me. So today, what topics we are going to cover? Those are mentioned over here. It will be around 8 topics. So we will be starting with the construction chemicals overview today. So whenever you come across the construction chemicals, okay, you might have some you can say they are products, okay, altogether. So these are just a imaginary, you can say illustration of how it looks, whether the application or the materials that are used at the site altogether. So there are various segments, product segments in the construction chemicals. So, what are the products that are made for the construction chemicals to be denoted? Okay, so it might be a combination of these 3 to 4 materials, whether it might be a polymer or powder material such as cement or aggregates or resin such as base or hardener, such as epoxy, or there is some filler material. So either you can say it is a combination of polymers or the powder materials, or you can say polymers or resins or resins or filler material. So altogether, this is a terminology of a construction chemical product that it contains these 4 products, or it might be a standalone basis, a single product will be there. That's all about the construction chemical in the basic part. And now we look after the segments that we are dealing right now. It is like eight to nine, like starting from admixtures, grouts, anchors, flooring, waterproofing, sealants and adhesive, concrete repair and rehabilitations, structural strengthening part, protective coatings. Today we will be broadly focusing on concrete repair and rehabilitation part.
Bhavik, one small request. You may go slightly slow because as all students are there, they may not be conversant with the technical part of chemicals. So go slow at your pace. Okay.
Okay, okay, okay.
Yeah.
Okay, sir, thank you. So these are the broader aspects of the like construction chemical segments which are over here. So in totality, I have prepared a short summary to understand what is like in construction chemical segment. Like if when I talk about the admixtures, so they are basically added into the concrete. So it might be like plasticizer, super plasticizer, accelerator, retarders, or air entering agents, shrinkage reducer, corrosion inhibitors. So if you look after all these names, they are basically giving a functionality to the concrete to perform a desired parameter that is known as an admixture. It is a liquid or a kind of powder material which has to be added in the concrete based on the certain dosage. Now moving to the grouts and anchors. In grouts and anchors, what happens? It might be like having a chemistry of chemical base like epoxy, or you can say specific one like anchoring solutions, which might be chemical base of epoxy variant used for anchoring, like you can say bonded anchors or post-install anchors. And in cementitious grouts, okay, when we are casting for a pedestal such as machinery or certain kind of you can say industrial grade required. So there are pedestal which are being used with which are precision grouts. Then next comes the flooring. As you know, we are living in a concrete kind of a jungle. Okay, so we always have a flooring requirement. After casting the slab, after doing some may go with the tiling, and some might have some other requirements such as epoxy flooring, PU flooring. Now, if you are working for different industry, like for an example, I will tell you, if you are into pharma industry, okay, so the pharma industry grade of flooring, and compared to that one with the other industries such as urea or you can say fertilizers, they both will have some different functionality and requirement for that floorings. For an example, a pharmaceutical flooring will have some requirement. It should be non-dusting. It should have like particular stability at particular temperature, but that not be the same with the urea or fertilizer grade. In fertilizer, there might be some chemical action which should not get on the floor. So they might require chemical resistant floorings such as PU floorings and some sort of you can say hardener which are dust proof agents such as car park. Okay, so when different utilities have a different requirement of our flooring system, so that are covered in the chemistry as a generic one over here. Next would be waterproofing. In waterproofing, we have like different terminologies like liquid applied membrane, cementitious waterproofing membranes, and integral waterproofing compounds, crystalline waterproofing compounds. So last two, if you see integral waterproofing compounds and crystalline waterproofing, they are basically admixtures, but they are part of a waterproofing, contributing their properties to give the crystalline property and form of crystals when come into the contact of the water. Okay, and now the liquid applied membrane, it has a utility, for example, wet areas or you can say exposed roofs or the terrace roof are there. So based on those requirements, like cementitious waterproofing coat would be required for underground water tanks where moisture is high. So every product has its own requirement and the functionality, the how it can perform to stop the action or the water coming from the concrete inside, because concrete is a permeable. Okay. Now next would be sealants and adhesive. So in sealants and adhesive, what happens? As you see, nowadays we are not using the general cement and aggregate mixture to put the tiles. We use ready mix bags. Okay, so some might be like tile adhesive, some might be a construction adhesive, or some might be sealants. Like there is an expansion joint, like having a gap of a 50 or less than 50 So those gaps should be filled. So we can use a sealant over there. In sealant also it has a like a different chemistry over here. In sealants, I will tell you like they might have epoxy, then silicon based. The different chemistry will always play out a role. That is why it is a construction chemicals. Like I previously narrated about how the construction chemical product has been defined. It is a standalone product or a combination of a four products. Now, the today the basic part that we will be covering in detail would be concrete repair, structural strengthening, protective coatings. So in concrete repair, what happens that it is a basically what happens. It might have some polymer mortars, micro concretes, rust remover, bonding agents, and epoxy mortars. So basically, what happens when you see a concrete has been spelling, okay, now you want to treat cosmetic repair. So you will need to require the corrosion because in concrete repair, basically most of the time, like 90% of the time, we are always dealing with the corrosion part over there. So we need to repair that. So we'll require some rust removers, corrosion protection primers over there. Then we might need a bonding agent to give the bond between the old concrete and new concrete. And if it is a more, you can say structural repair, then micro concrete is required. And epoxy grade mortars will be required for the industrial purpose only based on the different environmental conditions. Now, structural strengthening. When you are upgrading, like for an example, you have some certain building, okay, like G plus one or G plus two, which was constructed, you can say 40 years or 50 years back. Now the whole city has or that area has been, you can say upgraded, okay. Now over the time, what happens is that the utility of that building was like it was used for a residential purpose. Now that purpose has changed and been used for the commercial purpose. Now what has happened? They are placing some machinery on the floor, okay. Now there is some additional load taking place on the columns and beam or the structural elements or the slab. So we might need to work out on the modeling part and everything. We need to understand what is the parameter, like we have to increase the shear stress or you can say load disturbance will increase. So that particular section has to be redesign and upgrade that particular element. So we use different kind of systems like FRB systems are used, or you can say steel plate bonding or jacketing, or you can say anchoring fastening system. Based on the proposal, we propose that structural strengthening schematics over there. Now, in protective coatings, what happens after doing concrete repair and structural repairing scheme to just protect the structure from the environmental, like if it is in very corrosive environment. For an example, any marine structure located to a coastal area, it might have exposure way to, you can say, to the pollutants. So it might require some anti-carbonation coating. And for an example, some epoxy coatings are there for food grade coatings are there for in application. So different utilities or different purpose or scope will require different coatings. Or you can say there is a blast furnace, or you can say some industry which have a high ambient temperature above 100 degree. So you require some vermiculate coating such as fireproofing and intumescent coating. And basically today we'll be discussing more about the after rust remover. We provide anti-corrosive coating on the reinforcement part. So this is a broader perspective of all the segments that we are covering right now. But in detail, we'll discuss about the concrete repair going forward. Okay. Uh, Previously, we are discussing about the concrete repair. Okay. Now, let's look what the media has to say in last 1 year. If you see, as the major articles are from the you can say Mumbai market, but if you see the all those articles, what it links to that all the tall buildings that we are building, like we are building a concrete jungle, okay, but there is no maintenance part or you can say proper audit has been done. Even some buildings such as Roorkee Institute has retrofitted suggested to retrofit 20 British era buildings in the Shimla. So there are big chunk of maintenance requirement in the building segment. So we are just not building high rise building, but we should also make sure that with the pace that we are building the construction or giving the life to the new structure, we should also maintain the old structure at that same pace. That is what we can conclude from this news articles. Even other articles are there. Why concrete repair is very much significant plays a role. CPW has said that there are 90% of the audit has not been taken place for government buildings. Now, some major repairs in the South Mumbai requires 225 crores. So basically, just imagine the magnitude of the budget that requirement for one particular zone. And what when we are talking about government buildings, even some buildings are not audited properly or not even taken the building assessment part. So these all articles, what it links that what is the scope of building repairs and concrete repairs and structural strengthening requirement altogether in the market currently as of now. So now we will be moving towards the repair practices that are followed in the market or in the current trend. So what happens basically, there are some quality gaps. So what happens, there are specification often not achieved in the field. Like for an example, I told that the material should be able to achieve at 28 days M30 or M40 grade of strength, but it is achieving M20 because of not proper supervision or the quality material has not been used. It was a site mix or the symptom treatment. Just we focus on the visual damage, not on the root cause analysis. If there might be also a lack of understanding that how the deterioration has happened. Okay, there might be like that after certain duration. Like see, once the building has age, okay, the aging has start of the building. Like for an example, after 30 years or 25 years of the service life of the building, it cannot maintain or perform the same as it was performing for last 25 years. So it requires some maintenance. So maintenance needs to be carried out periodically over there. So documentation also needs to be taken care over there. But what happens in the market, that the asset owner or the building owner who has undertaken that particular building or that structure, it might have some issues which has not been solved, but they always have an end goal like we just need to extend the life with the minimum cost. So what happens, without they do those on repair or cosmetic repair the market, but they never consult with the proper structural engineer. So what happens, there are mishaps or the disaster. You might be saying that there were some collapse in the bridges, or you can say in the buildings in the Mumbai market itself or in the other states of the India. So that is a whole current state and the challenges that we are facing right now. So, what should be a systematic approach? Previously, I am talking about the concrete repair part for last 10 minutes, okay? But what should be defined as 3R basically? So, what are the 3R? See, basically, what happens in concrete repair, there are three principles. We should be able to identify whether it requires the restoration of the structure and the functional performance, which is defined as a repair. So, basic repair has been required over there. Now, next part is the restoration R. Okay, bringing the whole structural life to the original performance which it used to have previously 10 years or 5 years back. Or rehabilitation, like I told about the retrofitting and the strengthening part, you have to upgrade or retrofit the for your, like I said, for from residential to the commercial, you have some machinery.
You went on mute, Bhavik. Unmute yourself.
Sorry, sorry. Uh, wait a minute. Am I audible now?
Yes.
This has been covered or this has been mute?
Yeah, this is covered. Only 1 second it went on unmute. Mute.
Okay, okay. This also has been covered now.
Yes, yes, yes.
Okay, thank you. So now you might be wondering what is a like basic like I told previously that 90% of the problems are always related to the corrosion. Like for an example, after building a structure, okay, it has been a cover available, but what happens over the time, it gets some cracks, or after the curing there are some sinkage cracks. So what happens, some water enters into that particular concrete. So that is a pictorial representation when the water enters and comes in the contact with the steel rebar in the concrete. So what happens? The water starts to form cathode and anodic reaction over there. So there are pit formation onto the rebar which forms the corrosion altogether in the concrete, which starts the deterioration of the steel rebars and forms the corrosion. So that is all the reaction over there. Like anodic part is there, so we require some cathodic part which has a medium due to the water over there. Now, just you can say plan view is been placed below here, like how the corrosion starts, like how the cracking forms due to the corrosion. Before corrosion, in the plan section, you can see there is a rebar and there is a concrete part, and over the time, corrosion built up around it. Okay, like there were one, two, three pits are formed, then again four, five pits are starting to form. Now that corrosion starts to accumulate on the steel rebar. Okay, so there is some gap, and due to that arising of the cross section area around the rebar, those cracks start to form and it's eventually spelling forms of the concrete rebar, and it is exposed to us as a concrete repair has been required over there. So basically, why do concrete repair fails? This is a column representing how the corrosion might look on the rebar. So what happens, as I previously mentioned, that they have been using the site mixing, they are using non-standard product. There is no proper methodology, there is no proper supervision, even though the diagnostic has been done by the asset owner, but not with the proper structural engineers over there. So proper methodology was never there, and no mapping of the concrete schematics has been done or followed on site. Now, like an overview of general causes why the distress happens in the concrete building. So, if you see the majority of the part, it are due to the extreme loads. The design parameter has been changed. Like what it was used, like the structure was designed for a particular load. Now you are using for utility has been changed over there. So, as you know that previously what would happen, the concrete was not waterproof. Okay, so they might use some lower grade of waterproofing material or not standardized procedure or bitumen layer or something which degrades over the time. So maintenance was not properly done or the workmanship is not proper. Detailing of the products or the that requirement of the schematic system not being provided. Then poor quality of the concrete has been used, poor selection of materials. So basically, if you see that more than 50% of it contributes to that it is due to the extreme loads or the poor quality of the concrete and the poor selection of the material majority of the part. And the minor part which it comes, it is a waterproofing failure. This is the whole, you can say, overview of how the distress comes in the concrete building. Now, previously I have been talking about the repair practice that has been carried out. If you want to basically assess a building, like if you are like a structural engineer, okay, some society building comes to you and tells, I want to do a NDT report or you can say structural assessment. So there are four stages that we need to take place while doing the structural assessment. Stage one would be preliminary assessment, like inspection about why, what is the scope, what is a like a repair has been done, what is the history collection, like what basically a society members are looking out for that, like what what is their scope. Okay, we should do the one-on-one face meeting or individual meeting with the society and understand their scope and their requirement. Then next stage would be we need to plan like what kind of damages you can find, what are the member grouping, you can suggest what are the test planning that you will be covering based on your preliminary inspection with the society and site visit. Okay, now after doing all those, you might need to record all the visual inspection. Okay, so systematic documentation need to be prepared, photographic records should be kept. You need to specify at which particular location what particular damage has been mapped. Okay, so you have to prepare whole visual report of that. Now in stage 4, you will require to take a field visit and do a lab testing. Okay, so you will have some NDT techniques, non-destructive evaluation techniques or material sampling, like core can be taken out from the structural element at different location. We have to do the detailed analysis of both the reports and understand what the basically what is happening inside the concrete altogether through this field and lab testing part. So to arrive at a conclusion, we require these four stages to be taken place at for any structural assessment. It would be the same, you can say, for industrial grade buildings, for infrastructure, or for the any structure which is a concrete in nature, or even for the steel structures. So now we will be starting with the visual inspection. So as you can see, if you are on site, okay, you need to identify what are the causes of the distress in the concrete structure. Okay, so basically you might be able to see some cracking, spelling is there, disintegration is there, dusting can be coming out, honeycombing, or the structural element has been buckled over somewhere, or some sort of corrosion or cavitation has been formed on site. So these are the different pictures that can be used as an overview to understand how the distress looks in the concrete structures. The basic one you will see is the corrosion or the spelling part. That is why only you have been called, because normally honeycombing would be in the new construction or the during the repair phase when the proper material selection or the proper mix was not used. And the one of the major thing, whenever you are visiting site and you see a crack, okay, there might be like structural grade cracks and non-structural grade cracks. It depends on your So you should have a crack gauge. So it defines from 1 zero 0.3 mm to 10 mm, a different kind of, you can see over here in this picture here. Now, since you have look on all those pictures and images to understand how the cracks looks, okay, but how to define what are the different types of cracks? So they can be defined into two categories: before hardening and after hardening. So when a concrete is not set and when it is been set and cured, okay, so there are some different classification. Like for example, before hardening there might be some movement in the concrete which are due to the form movement or the subgrade movement. So or the late joining has been happening, or the plastic stage cracks, shrinkage, or the settlement cracks, or a freezing. When the concrete gets hard, okay, so there might be some different, you can say physical, due to the alkali reaction, rise shrinkage, or the restraint shrinkage over there. Now, due to the some variational or seasonal temperature, you might see expansion, contraction. So there are thermal related cracks over there after the hardening of the concrete. And like I previously told, that the structure might be in some different area or the environment, like chemical. So like in the coastal environment, so some there might be have some pollutants, or in the urea plant or the fertilizer plant. So there might be some sulfate action, or you can say attacks taking place on the concrete, which might be the cause to crack in the concrete over the time. And last part is basically the retrofitting or the strengthening part, that is a requirement, but it might be due to the structural changes, like overload has been taken place, improper design, that there are some fatigues and creep action, or you can say earthquake has been taken place. So those kind of thing might come under the structural after the hardening stage. So these are whole, you might be able to correlate with them if you see any cracks. So basically, if you see some earthquake, okay, so basically it is a structural crack has an occurred after the hardening stage. So that kind of crack we have to mention in our report when we are saying the visual inspection. So now NDT, you might all have been able to have been came across this particular terminology. So why we do the NDT? Basically, it is used for concrete strength assessment, chemical analysis, and corrosion assessment. So these are the whole tests that we covered during the NDT part: rebound hammer, UPV, core testing, carbonation, chloride content, pH measurement, half cell potential, cover thickness. Now, these are some basically the IS code related and some pictorial graph to understand how rebound hammer looks. So it will have some average rating. It will tell you the surface grade of the quality. UPV will also be have the same, depend on the grade of the concrete. It depends on the parameter of such as a velocity part over there. Now, half cell potential based on the megavolt, we might be able to understand the potential, whether the probability of the steel corrosion is taking place in the particular segment or not. From core, we will have the actual strength of the structural member. And from carbonation, we can understand the pH of the concrete, whether it is less than 9 or greater than 12. So just to summarize, like for our understanding, what is accuracy of each entity method? Like for rebound, it might be less. UP will be it will be less, but for you can say code, it will be always high. And from half cell potential, we are just coming across a probabilistic method. In this chart you can currently understand how it works. Like for rebound and ultrasonic UPV, it will have like just surface hardness will be able to understand and able to correlate that what are the voids and uniformity. From core testing, we will have a true compressive strength, okay, actual what we are able to get. Now, based on the all this, we will be moving ahead, because if I cover, it will be taking a lot of time. So if you have some doubts in this, we can always come back on this part. Now, previously we have covered from structural assess like stage 4, stage 1, 2, and 3. Okay, stage 4 has been also covered. Now we are moving to the new section of our discussion. It will be a design, how to design a repair methodology altogether for a concrete repair. So, what are the parameters that we need to be taken care? we need to take care for repair materials. So what are the physical properties? What is the chemical compatibility? What is the performance requirement? Whether the it has a low shrinkage or the what is the thermal expansion, you should understand all the physical parameters over there. Then what is the pH of that particular material or the environment over there, whether it is low permeable, whether it requires chemical resistance. And performance requirements are basically like how the bonding and the mechanical, like whether it is under static loading or the dynamic loading, and what are the minimum criteria or the curing period that we might be able to come, because some structures might have like a requirement of having a curing of 3 hours or 1 day. So basically product selection need to be taken place while designing a repair materials. Now what are the different types of repair material? Like previously I have told about the polymer materials and the cementitious material. They are nothing like you will have like in cementitious material polymers are like their PMM or the micro concretes are there. Some grouts are also over there. And in polymer what happens, like you might have some acrylic polymers, then epoxy motors are there. Now, what is the selection criteria for any material? It is the same parameter that we have discussed, because we should be able to define the long-term exposure and long-term scope of the material based on our objective. Now, in broader perspective, what is the systematic approach to a concrete repair? Uh, if you see any concrete failing at your nearby, okay, and you are being told to do a general concrete repair. So, what is the general methodology, or you can say general approach that we need to take place over there? First, if the element is spelling, okay, we should provide some support so that if we are trying to dismantle, okay, that particular concrete from there, it might not come under deformation immediately. So there is some support over there near to like for an a beam, we should have props of like at the ends or uh, at the supports we need to provide. Then surface preparation, we need to dismantle. Then like for an example, if we are providing some corrosion control, okay, because basically we cannot control the corrosion, we can only delay the corrosion. So there are some, like in the previous corrosion basic, we are saying that anode gets reduced, the mass of the steel rebar gets deteriorated, okay, so we can use some sacrificial anodes. Basically there are some zinc mass with the embedded motors which are attached to the steel rebar. To the corrosion will take place in the zinc bar compared to that steel rebar due to the some potential difference. Now, as you have seen some reinforcement, okay, has been corroded, so you might require some corrosive and anti-corrosive treatment. Now, based on your injection grouts, you might provide that cement grouts or the epoxy grout. Now, after doing the injection grout treatment, you will require some bonding agent to do some localized repair. And if it is higher grade, then you will need to have like micro jacket section enlargement based on the repair schematics. Now, after doing the repair, you might require some curing compound, because we cannot monitor each and every day whether the curing has been done by the labor properly or not. Then to just monitor all these steps by from step 1 to step 10, you might require some quality checks, okay, or you can say some checklist should be there or quality assurance plan which has to be submitted during the proposal stage itself. How you will maintain the quality of whole your execution. Now, last stage would be after the curing, we might need to provide some protective coating to protect like from external phase, like for a building, it might like we are doing some paintings, okay. So exterior, we require some waterproofing coatings or decorative coatings. Same what I have discussed, the different phases, some graphs are pictorial representation is there. So this is how you might need to support. This is how you will be breaking. This is a corrosion control sacrificial anode that has been connected. This is a rebar that we have been treating right now. Then this is a how the nozzle grouting takes place. If you see there is a nozzle and it has been covered. The crack has been covered properly. When we are applying bond coat, proper geometry has been taken care over here while applying the bond coat. Now there is a rough surface on the polymer final surface, so that additional like plastering can be taken place after the polymer treatment. Now, if you are not going with some polymer treatment, you might be requiring to have some section enlargement. Depends on the scope or FRP system. You are not going with the micro concrete, but you are moving ahead with the FRP system or steel plate bonding. It depends on our schematics altogether. And this is a curing compound it's placed on. and protective coating. Now, previously I was talking about the surface preparation part. Why surface preparation is the basically the, you can say, the main part of a concrete repair. See, basically what happens at the international level, we have defined CSP 1 to CSP 10. So what kind of hardness is required for what kind of a treatment? Okay, like if you are just selling any particular material, like in the injection there was some cracks. Okay, so having those kind of cracks we have to fill. Okay, so basically sealers or sort of thing might be able to satisfy CSP 1 and 2. If we are going for some protective coatings, then the surface preparation need to have some like CSP 3 to CSP 5. Some polymer treatments that we have to do, like polymers we have to take place, then CSP 5 to CSP 9. Then if we are placing some additional like micro concrete, it might need more hardness, like CSP 10, ranging from 5 to 10. So this is, you can say, the basic part if you are trying to bond. So basically what people thinks na, okay, if you have done just applied the bond coat, it is good, more than enough. But I will tell you, the additionally the mechanical adhesion or the mechanical bonding, if it needs to be taken care, then you should be always take care whether during the inspection of the concrete repair execution, that what is the CSP and what is the requirement, whether the hardness or the profile has been properly achieved on site or not. Now, previously I was talking about the after micro concrete or before PMM, there might be some changes, like it is not a cosmetic repair. Now you are being required as per your project requirement. You have to propose some strengthening because your residential building has been taken some load and it has been now used for a commercial building. So there might be some section enlargement. So there might be some external reinforcement or load distribution criteria that you might need to satisfy during your project phase. So, so what it will cover, it is basically increased load capacity or different kind of system like FRP wrapping would be done based on your economics. We would propose some these methods of strategies for the strengthening in the concrete repair. Now, what happens? You have done everything proper, okay? But whether we should have some framework to assess the material quality, okay, or the repair project quality, how to maintain. So we should always use some material control parameters, like a standard grade of material has to be used, like ready mix has to be used, not side mix has to be done on the on site, okay? And workman has to be properly trained. Like if you are using certain product from a manufacturer, okay, you should always tell that manufacturer to perform a demo, or you should do a, you can say, mock-up on site to understand how to implement. And you should also have a one-on-one session with your manufacturer to train your workforce or your team altogether for that particular project. You should always be aware if something goes wrong, so what should be done, like do's and don'ts of the products that can be achieved through your manufacturer's guidelines, or you can say you can always contact. Now, like what happens, we just give some structural assessment, we give some recommendation, okay? Now, we should also monitor, like during the pre-repair phase, what was the strength, and during the execution, we were monitoring, we have some checklist, okay? Now, post-repair, we should also have that material analysis, what we are going to achieve, have we achieved or not? Like preparing some cubes over there, if you are doing micro concrete, okay? So whether we are achieving our target strength or not, those parameters in the quality assessment needs to be taken care. Now moving to the next part, it would be like what the future maintenance strategy has to be taken care. So basically documentation, periodic maintenance or preventive maintenance, like do's and don'ts. These are the repetition part. I will be moving forward. So this is the whole graph, like why we are doing concrete repair. The over time the performance of the structure will get deteriorated, and it will, or the over the service life it will get downgraded, okay? So doing some maintenance, we propose that this graphs gets a little up, so performance will enhance. So periodic maintenance is required. That is a whole reason behind the approach, right approach to maintain the structural life. Okay, so now whatever we have previously studied about how those four stages has to be taken care, what is the design methodology, what are the execution part, how the quality framework works out. Let's do a deep dive into the case study. This is a four-story RCC frame residential quarters at Mumbai. I would thanks CPWD for handbook having this case studies. So if you see what here has been done, like what I have experienced, stage one, preliminary inspection. So when was it the construction taken place? When you are going for a investigation, what is the structure? What is the nearby location over there? And what are the number of structures that you are visiting over there? Then through visual inspection, what kind of cracking you are seeing? What kind of reinforcement or whether the loss, whether the concrete cover has gone? Are there some cracks in the walls? Or previously, what sort of concrete repair has been done or damage part you can see from your general overview, you have to record all those things. So here they were able to understand that poor quality of the past repair has been taken place, and some building has collapsed and some are near collapse. So assessment based on that we can have to prepare the visual inspection report. Now this is like some photographical representation how the building looks like for a one block of the type 3 quarters. So basically there are some cracks, there are some reduction in the corrosion related part of the balcony. Now you can see there is a damaged chajja over here. There are some RCC column at the plinth level projection. Whole plaster has been have corrosion due to the steel reinforcement. Then there is a whole, you can say, lateral crack going up to the a certain height through visual reports. And there are some ongoing structural repairs taking place. And how the structurally repair block looks before finishing. So, like in stage three, we are looking for a lab test, like NDT reports and lab test. So what we were able to find, like the core strength is like 20, 73 MPa, then carbonation, rebound hammer has some reading like 65% of the readings had like 10 to 20 as a reading over there of surface hardness. In beams, it were a different range. In ultrasonic, you might see the range as like 0.64 to 2.5 range. The majority of the readings were less than 2, okay, in the velocity. Majority of the reading were in the 60% criteria. In half cell potential, we can see the corrosion probability. 20% we were less than the probability of the corrosion, but 57% were telling that it is a kind of, you can say, uncertainty, and 23% told that 90% of there is a probability of corrosion through the half cell potential. So doing some chemical analysis, we able to find that there was a sulfate availability in the concrete structure. Chloride was about the limit since it was exposed to some refineries over there. So what are the conclusions that we are able to grow come from those past? So this is whole repetition that what I have mentioned. Like there was a chloride, high humidity is there, hot climate is there. Then the environment is a little bit acidic. Okay, so you have to give some conclusion based on the your visual inspection, NDT reports, and what you have observed on site. Like there is not adequate concrete cover. Now, after preparing the four stage conditional assessment, you need to prepare some mapping part. Okay, minor, whether it is a minor damage, major damage, or severe damage. On based on that, you have to prepare some altogether. You can say the this particular schematics. So for minor repair, like I have previously mentioned in the structural repair part, systematic approach, it might be remove the plaster, do the polymer repair, do the crack injection, then apply the plaster, cover it, and provide the coating. So it might be a cosmetic, not a permanent one, but a temporary solution. The same has been shown over here for the injection grout, how it looks after the pattern, and what are the techniques that has to be followed. So for severe damage, like there was some carbonation to the reinforcement. So they have proposed some option one and option two based on the depth or the loss of the concrete mm, or you can say spelling of the concrete. If it is less, then you can cover with the polymer localized repair. Or if it is more than, you can say minimum 100 it is that, then it would be best to go with your RCC jacketing with the micro concrete. And if it is severely like how it looks, this is a pictorial graph. See in picture one, they have removed all the defective part. They remove the corrosion product from reinforcement, applied anti-corrosive, then patching with the repair, like resurface to the required parent concrete. Now they have applied the finishing protective layer on it, or you can say finishing has been done from a plaster, then covering with the protective coating. It is the same methodology. Previously, what used to happen, as since this case study is little old, so you might be coming across shortcutting. Okay. Now in market, we also have some polymer grade, spirit grade motors available. So the same material which we are using for, you can say ready mix, which is a polymer. Okay. It can be used for spray grade such as shortcutting also, or gunneting kind of thing application, which are in wet condition or the dry stage. So this is a schematics of how column repair by gunneting looks. Like this was a section that needs to be extended. Okay, so they are given a form work over here and gunneted over the short rating year and year, and properly they are done the all the shuttering part. Like flash code has been applied after dismantling. So this is how basically the case study one ends over here. So we are already at conclusion. We gave them proposal what recommendation needs to be taken place over there. Now we have second case study. This is very interesting case study. Okay, this might be not looking on day-to-day basis over here. It is a VIP conference center at Delhi. So what happened over here now? I will tell you. Basically, it was constructed in 1957, renovated in 1983. Investigation was carried out in 1990. Okay, so there are three blocks: auditorium, admin block, and rear block. So basically, RCC frame structures were there, and steel roof on the terrace part. Now, what occurred during the preliminary inspection? Why they were being called over that? Because there was a fire broke out, okay, in the false ceiling. So the whole second floor was exposed to some fire. So that same fire has been came to auditorium and extended and heavily damaged. And the fire was continuously, you can say, more than for a time frame of more than 1 hour or 1.5 hour. It is not defined particularly. So what were the observations when you go over there? Okay. So basically the roof trusses were collapsed. There were major cracks in some concrete members. Spelling was observed. Exposed reinforcement in structural members. Plaster was damaged. Minor pilling can be observed and excessive deterioration in certain columns. So due to the high temperature, what happens to the concrete? You can basically see in this case study. So this is how the whole auditorium looks after fire and some other parts of the building. Okay. Now doing some uh, NDT test and lab test, we were able to find from the debris itself what kind of temperature they were exposed approx. Floor level was around 200 degrees Celsius and roof level it was 1100. Due to the no ventilation or the confinement, the temperature might have rose to that sort of temperature. It is a approximate temperature from inspection they have carried out, and from core test they were able to identify what sort of MPa they were able to get from columns, beams, and slabs on an average basis. So columns at 16 MPa, beams at 18 MPa, slab at 17 MPa. And based on the assessment of the UPV, they were able to identify on the velocity what sort of percentage of the readings. If you see, it is a mix of poor, doubtful, and medium. So it is a whole. You cannot depend into one. Same goes with your rebound hammer. Now, this part, laboratory test, it might be a little higher side, like when it was exposed to certain temperature. So, what is the strength? So, the specimen, like 20 number of samples on site, they found that 80 to 90% of the strength, like for lower than 200 degrees Celsius, they are able to retain their strength. For a higher temperature exposed, they were able to 70 to 80%. And if it is beyond 300%, they in two specimen they found 60 to 70%. So nowhere they were like losing the strength more than 50%. So what is a differential temperature analysis found conclusion over here that the slabs and beam were exposed to less than 500 degrees Celsius and columns were exposed to higher grade of the temperature such as 500 to 570 degrees centigrade. Now, what conclusion we can arrive from that? Fire damage members can be classified into class 1 to 4 based on your visual inspection and non-destructive test. And we were able to understand that there is some residual strength already available from our test results. So based on that, this whole graph like table has been prepared. So class 1 would require like uh, sup- superficial damage has been observed over there, which has less than 200 degrees centigrades of the temperature Celsius, the temperature. So what would be the repair? It might be a structural repair, but based on the visual inspection, then class 2 will have a non-structural grade ranging for the temperature of 200 to 300. Class 3 will have some different temperatures grade. Class 4 will have the highest like heavily damaged or collapse. So they might require some heavy structural retrofitting schematics over there. So as you can see, these are just generic recommendation that they have suggested for repair. Like for superficial, you can do the cement plaster. So basically, structure has been not damaged. In class 2, there were minor or non-structural repairs. So PMM motors or epoxy grades motor can be used over there with or without mesh. Now in class 2 repair, like there is a significance, like 60 to 70% of the residual strength has been lost. So we have to do shotcreting, RCC jacketing, epoxy grout injection, cement grouting for honeycomb areas. And in class 4, we are able to like whether we have to demolish altogether the structure, it cannot be used or treated because the whole core strength has gone over there. So we can recast that whole particular section, or we have to strengthen by adding some structural element or doing some analysis and provide how we can do it. There are some side photos also. So this is how the auditorium looks after repairs and after the finishing, and some column repairs, jacketing, how they have taken place. Now they have like side photos during the execution, how nipple was fixed and crack was filled by using, then how injection was taken place, now how repair motor has been applied, how shortcutting has been taken place in the process over there after doing all the repair part, like steel reinforcement and everything, localized repair. Now this is important, okay? This might be the last slide of this whole session. So whenever you get some inquiry, or you can say you are taking some project altogether as an student or as an structural engineer in your career, okay, you should always define what is the objective, what is the scope, and what are the methodologies, and whether it enters into the repair phase, restoration phase, or rehabilitation phase. If you are able to identify that, then only you will be able to map and able to get this done, to understand and classify them based on this, whether we have to do the class 1 damage or class 2, class 3, class 4. So basically your damage you are just mapping and giving a whole method like what can be done, whether it is a superficial damage or minor cracks or major cracks or heavily damaged. So if you do the proper mapping, then only you can propose and you can understand the client what sort of methodology has to be taken place at particular stage. So this is a requirement. This is the 3R that we have discussed previously in our during and before the corrosion basics. So always whenever you sit with the asset owner, you should define what is the objective, what is the scope, what are the methodology before coming to the economics part. Uh, Okay, so the whole presentation has been done. So you can ask me any question.
Wow, great presentation. I first of all thank you, Bhavik, for a wonderful presentation, and certain parts which you covered were really new to me, and probably as we discussed during finalization of the session, to give this presentation in 1 hour is a challenge in itself because there are several charts are were there are several tables are there, and to cover them in 1 hour was really a challenge. But you did a great job in 1 hour. Now it's time for question answers. So please feel free to ask questions, students. So to start with, I have put some questions in a chat box on myself. I would request even Aniket is there from IIT Roorkee, who is working with Stantec now. Then there is Mr. Nihal, engineer Nihal is there. So in my team, engineer Sanket Mali is there. So please feel free and ask your questions on the session, so that even you get a benefit out of this session, as well as the speaker understands that you have understood the topic. Yeah, so I will ask you in a reverse order. As you were covering the session, I was putting the question. So I will ask him in a reverse order. So you mentioned about that case study about fire, okay, which is very interesting case study, and I need to really have a look into this. In class 4, where the structures were dilapidated and completely collapsed, okay, so some of the things you repaired using chemicals, okay. So
Hmm.
my question is, how about that chemical, the stability of chemicals itself at a higher temperature? Suppose in future, if there is another fire episode, so are they tested? These chemicals are tested at a higher temperature.
So, in case study, they are not mention everything, but as an side exposure, like experience, I will share what can be taken
No,
care.
I mean you are representing FOSROC. So in your company, do up to what temperature it is tested? Like 100 degree, 200 degree.
Okay. So basically, what happens? I will not talk about any like manufacturing or you can say any product related part, but I will discuss
Yeah,
about the whole philosophy of our
first
design part.
philosophy.
Okay. Yeah.
Yes.
So, for an example, your some concrete jacketing should be taken care. Okay, it was exposed to some fire, exposed like a column was exposed to fire, so the whole cover has some blackish or you can say lost the strength. Okay, so we had removed the whole cover. Okay, on site, and after removing the cover, we took the core. And we understood the concrete residual has the 80 to 90% of the strength available over there. So the concrete cover has been again done with polymer mortars or the plastering has been done. Okay. Now what happens in
Mhm.
the future? We don't want to have that sort of mishaps to be repeated. Okay, or it might be in that particular environment. Like for an example, if it is in some blast furnace sort of industrial grade structure. Okay, where the temperatures are always above 100 degrees Celsius or 200 degrees Celsius. Okay, that structure will now require some additional because concrete itself can sustain up to 100 degrees Celsius, but up to limited hours. So what we would do, we would have some coatings like vermiculate coatings available in the market or some fire rating coatings from uh, painting manufacturers. Okay, so like based on your temperature, ambient temperature and the service temperature, you would do those coatings on the structure. Because what happens, like if you ask for the epoxy coatings or epoxy mortars, they will debond after going beyond 70 degree or 60 degree, so they might not do that well. So that is the reason we should always do, whenever we are doing a concrete repair, the end product should be with the protective coating. That's why I mentioned in this slide that whenever you are came across any of that building assessment or you have to do some NDT or recommendation for the repair, you should always have some objective scope and methods.
Mhm.
Because what happens in India, what I have understood from last 7 years of my market exposure, people always talk about the money part, but they never understand why and what and how. When we
Yes.
discuss this part, we are able to deliver the fabulous product and fabulous service and fabulous system.
Mhm.
But when we focus on economics, it might not be that economical. But it depends on the end user if we are able to put up the you can say justification properly. That is why we always need to map everything from start to end. That is why a preliminary inspection report with the asset owner. So basically what happens, I get a call, and as a specific engineer, I will tell you, I don't suggest the product directly, but I will go have a site visit, understand, I will record some things. I will meet some structural consultant who are already engaging in that project, and accordingly I will prepare my BOQ. Because after the methodology or recommendation, there is a requirement for the BOQ which is being prepared by the specification engineer or the structural engineer. So having this data is very critical, just not for me, for every engineer who has been associated with the project. And if any engineer tells you on the spot that you should use this particular project, like product has to be used, then either has he has been experienced or associated with the owner, so he might be aware of that particular, or he might have not in-depth knowledge of what is the scope, what is the objective, and what are the methodology. So that's why at the start of the presentation, I said you should always include a structural consultant whenever you are preparing this. Even as a manufacturer, sometimes what happen, customer comes to us for a preliminary inspection. So we as an engineer also has to give some generic or even say general method statement. So we might not indulge in the in you can say very much depth, but we might always suggest what has been occurred in the structure, and we will always tell them to do the NDT lab test. Hello. Uh, wait a second. I am able to see. Wait, I will wait. I will just reconnect.
Yeah. Now we can see
Okay.
you. Okay, good.
Okay, sorry. Actually, that there was some glitch in the network, I guess.
Okay, I guess so. Yeah.
Yeah.
Please continue.
So, without any structural engineer, any project for concrete repair is impossible. But also, without knowledge, we cannot propose any solution. That is my understanding as a manufacturer. Because all the presentation content
भेज
is
दो
very
ग्रुप पर
generic. So, what I suggest,
भेज दो ना
always
ग्रुप पर
focus on the system.
एक
Whenever
काम
you
करो
are
ऑफिस
providing
के
any
ग्रुप पर
solution
भेज
or
दो
any discussion has been taken place and with any asset owner, with any project manager, always discuss on the solution.
Solution. Yeah. Uh, Guys, any more questions? Please
Rit-
feel free and put in the chat box.
Rutvik has a question, I guess. Yeah, raise a hand.
Uh,
Sir, in the continuation of Vivek's question, I want to just ask that there is some chemicals you said that for fire resistance, right?
Hmm.
So, with the degree of temperature of fire resistance increase,
Hmm.
there is some duration that chemical will resist the fire at
Correct.
certain time duration. So,
Hmm.
is that fixed duration for such chemicals, or is that with the increase in temperature, it will not last long up to certain duration as particular vendor stated?
See what happens. Let me narrate the question back, like rephrase the question. As you told, it is very true that every chemical product that you are using might have some
खाना
sustainability
लाया
or
क्या
the capability to sustain up to particular hours. Okay. So for an example, one particular product will have some rating
चिमनी आ रही
that it
खाना
can sustain up to 4 hours, three
बहुत
hours.
दिन के
Okay,
बाद
so
रजवे चिमनी आ
it
गई
might have some rating like A1, A2 based on the test parameters. Okay, but that's why I told that it should have a scope and objective defined. So if you are already aware what are the temperature ranges like ambient temperature and the service temperature that structure is going to be exposed. So always choose for the higher grade of the temperature range for the protective coating. If you are using
नया
just for
गाड़ी है
a
मारुति
prevention, like
सुजुकी विक्टोरियस
any commercial building where the fire, those temperatures are not taking place, but it might be that it is an industrial sort of machinery or there. In case there is some, you can say wear and tear or the breakage or the maintenance is taking place, and there is a chance of getting some fire. Okay, so there might be a chance that it might only be exposed to certain hours. Okay, before the fire breaks, like fire brigade breaks and distinguish the fire. So for that particular requirement, we might use that particular chemicals or the coatings. But if you are like continuous exposure, so always have the higher grades of the service temperature that can be used over there.
Sir,
so probably
but
for sustain,
there is a change
yeah,
in temperature. There
Hmm.
is a change in temperature in the case studies that there is a 500-degree temperature at the certain level, then at the roof level there is a 1100 degree
Hmm.
temperature. So
Correct.
due to that change in temperature, that fire rating will be changed, or we have to go for a higher grade.
So basically, what happens whenever see the in what I was able to understand from this case study, the roof trusses were exposed to high temperature because it was completely confined. Okay, so there was no proper ventilation
Mhm.
over there. Okay, so due to that,
Okay.
the higher temperature were exposed. Okay, now whenever you are choosing any product, okay, you might always like for an example, any product or any manufacturer suggest you any product for any temperature. Okay, so they will always give what is the sustainability of that particular product for a particular range. So if you are exposing for 4 hours or 3 hours, it will be mentioned in the TDS, and also the temperature that it can sustain, like 50 to 100, 100 to 200, or up to 500. So see, even today in refineries we have like temperatures going beyond 500 or 200. Okay, there also we have some structures. So there are also some temperature changes. Recently, in the month of in the month of March, I had a site visit for a refinery where there were certain changes like of the temperature, like 100 degrees Celsius were there. When I had gone on site now, what I understood from that, the coatings were good in like there was no problem in the coating. But what happened due to the continuous exposure to that particular temperature, the decoloration has been taking place on the coating. So the film thickness it is reducing. Okay, so over the time, as I told you, the proper framework has to be taken care. Proper methodology, proper strategies needs to be taken care. Like asset owners should be aware that after 3 years, I have to recode it again. So we have to maintain that film thickness over there. So same will be in this case also. But it was a like a incident in the auditorium. It might be not exposed to that sort of temperature. It is just a case study where we are able to find from the debris that it was exposed to that particular temperature. So understanding the site, going on site, we have to make sure what we are able to grab from that thing. If on a phone call in a March, if I have told that I have some particular product available with me, then asset owner would be like, everybody is trying to sell me, okay? But when you visit, when you suggest them that your product has not failed, it is just the film thickness has been reduced because of the continuous exposure. It has not been taken care or it has been tested, okay?
Hmm.
So during inspection, we should be aware what is the product applied and what product we need to recommend it, so that end user understand what kind of economics or the future repair methodology he has to be undertaken or needs to be ready for that particular budget. Because for refineries, they have a huge budget, okay? So they are aware of this whole methodologies, but it is not the same case with the other asset owners, like for an auditorium or the residential building or the commercial building. So every product has their own, you can say, do's and don'ts. But understanding the product limitation is also a part of a structural engineer, or even as a manufacturer. We should always guide them what is the product limitation. If I tell that this is a super product, it doesn't work in that way. I hope I have answered your query perfectly with that example that I have.
Thank you, sir.
Yeah, great. Is there any structure? Is there any structure which is tested post
काय
repair?
खाल्लं का नाही काय खाल्लं का
Uh,
बरं
so
झालं
basically, what
बाकीचं
happens
काय
in India, there is no some practice as of now. But when I used to
हे
work
कर
with Sanrachna,
फॉर्म कर
he basically is a top five, you can say, repair consultant and contractor repair.
हां
So
ठीक आहे
it
मी
is like
बोलणं बोलतो
Tanenki. So based on the requirement on the end user, we would do the NDT periodically. So it will have some contractual period. What repair that we have done, we will give them the data that we have performed, and this is the whole which was like pre-repair and post-repair over the years, whether it is sustainable or not. Because we come across some different structure during my tenure over there, that we have done the repair for only for 5 years maintenance only. After 5 years, the building is going to collapse.
Okay,
So
okay.
there are some end cases which requires the asset owner approval, because if he is not able to sustain for 5 years also, then we provide stability, okay, for 5 years or 10 years based on normally not more than 7 years in the industry standard. It might depend, like if we are dealing with some regions, so they might have some contractual terminology like 10 years of stability should be provided when you are proposing some extensive repair or so. It depends. We do the testing, but it should be. depend on the scope with the asset owner. Because as an structural engineer or even as a civil engineer, we cannot propose everything to the customer unless and until he is not onboarding with us, because we don't have any proper guidelines in India as of now. When we are doing some, like say, repair, so this should be like A1 and A2, like sort of thing. We have to compare those repair, what was a pre-repair and post-repair. But we usually do for customers who require those sort of things, but on the additional cost basis.
Okay, understood. Great. So, any more questions?
Hi, Bhavik. So my question was related to that only. When you
Hmm.
release the stability certificate, so what is
Hmm.
the confidence or what are the probability conditions you usually mention when you provide it to the client?
Very good question.
Because uh, yeah, you understood, right?
See, I will just correlate this particular example, like stability certificate, what provides? It is the assurance of the quality repair or the execution that you have taken place. You have used the proper methodology, proper materials. Okay. Now, what happens in, I will discuss industry to industry. In civil, we are not installing any part which can be inspected on day-to-day basis. Okay, like we usually do with the mechanical component. Like for an example, if you are installing any lift, we know that periodical inspection can be carried out, and we can provide the certificate for 6 months and for particular periodic for life. Okay, but in civil it is not the same. We just come in a picture for once, and after 5 years or 10 years, based on the uh, requirement, we might be over there. So stability certificate altogether helps us to that we are providing the best of the quality of the services. So it is trial and error method. Okay, if you have done the proper NDT, proper assessment, proper diagnostic, i am I can assure you, even we are providing a good service, because civil repair doesn't falls easily. But if the quality repair or the proper mapping has been not done, then there is a chance that whatever structural stability certificate that we have provided might fail. Because for an example, if I tell you the service life of a building which was supposed to be 50 years, now at the end life of the 50 years, right at the curve, the performance already degraded. Okay, now just to earn some money or to play some economics or some political angle is there, and you are trying to repair and just give one or 2 year, and you provided a stability certificate for 5 years. These are just assumption. Okay, so there is a chance of the scrutiny. There is a chance that the engineer who was associated might get jailed for that particular wrongdoings. Okay, but India, it is usually the other way. Only the engineer will be scapegoat over there. So my always you can say suggestion or the advice to every structural engineer or every civil engineer would be, always do the preliminary inspection, and always suggest that this might have some certain limitation. So don't go and always case to case basis, always provide the structural stability. If you have done the analysis, okay, you have taken out the core from different parts where it is very much, you can say, doubtful. So rely on the core testing part compared to NDT and rebound hammer, because they are like surface grade concrete quality, not in depth. So do some chemical analysis, do the those same grade of concrete, design the model, and see what you get. Okay, what sort of repair methodology and how it can sustain. See, because defining and coming into the economics, it might be little challenging. So always, whenever you are giving some structural stability certificate, it has to be case to case basis. Okay, that is my advice. If you are like legally bound to provide some service to that particular customer.
Great. Any more questions, or should we wrap up the session?
And one question. So let's suppose if there is one building and you have to increase the storage of that particular building. So you give couplers to reinforcement. But when it comes to concrete to concrete connections, so what are the methods by which you develop those connections?
See, basically, it has to be undertaken the proper structural analysis. Okay, you should need to understand which particular column, which particular beam require the strengthening or enlargement part, or what is a section that it requires. Okay, particular stresses or the load distribution taking place on that particular where it fails. Okay, so accordingly, strategies would be like section enlargement, strip plate bonding, additional FRP from the external side. Based on your combination, you might propose those solution. based on your analysis. So you might need to look at the structure and define the scope, because there might be some limitation that you cannot increase the section, so you might go for FRP. There might be some limitation with the FRP as a costing, but you might go with the steel plate bonding. So basically what happens for a FRP, like you can say there might be some shear requirement, flexure requirement. So accordingly you will design the schematics over
So
there
you guys
in
do
the building.
model this into the FE softwares and get the actions,
Currently, the manufacturers that provide
because I
supports
haven't seen anyone who are in this field, let's suppose LT or FOSROC. They do have these structural engineers which do exact modeling, and as
actually.
per those modelers, they do get the actions, and corresponding to those actions, they do give the systems.
So basically what happens, we basically discuss this part with our structural consultants, okay? Whenever the consultant gives us the proper data, we prepare and we prepare the whole design. So we provide the design support, okay? So we also have in-house structural engineers with us, okay? But what happens
Okay.
as in manufacturers, let me finish. As a manufacturer, we don't provide the complete details to the end users, because it has to be reassessed with the structural consultant. So the customer will not have that access completely. It will depend on the structural consultant, because it has to be vetted by the structural consultant, because we are a manufacturers, okay? We can say anything to you. So in field, we provide the technical support. So it's not like the FOSROC is not giving support. It is not required. We have some PhD holders also onboarded with us who are working as an, you can say, product development team. So we have a complete R&D team dedicated to concrete repair and structural strengthening part. And we also have a huge quantum of case studies with us. But as we are limited to for this session, I'm not able to share those details or uh, project related
Mhm.
confidential data, because it might be not good for the company. But we do provide the
Mhm.
support
Mhm.
if required.
I understand.
Great. So now we should conclude the session. Before we conclude, I would just summarize what we discussed today. Is Mr. Bhavik started his presentation with what are the types of chemicals, what are the mixtures. It's not a single mixture. He said that it is a blend of two, three components. Then he discussed on the classification of the chemicals, then chemical industry, like in pharma, the flooring may be requirement may be different. Then in the car parking of a residential areas, different. It is the same flooring, but different chemicals may be required. Then waterproofing, sealant, structural strengthening, protection, protective coating. He just elaborated in his classification of the chemicals. Then he spoke about the status of repair in media, which is currently we see in Mumbai. Then current status and challenges. What are the challenges? Systematic approval approach. These three are he discussed about repair, restoration, rehabilitation. Then moving ahead, he discussed on 90% of the problems are with corrosion, like spalling of the concrete is seen, then area and the volume of the rust which is increased, because of which, and one diagram he showed. Moving ahead, he discussed on the reasons of the corrosions, like poor quality of the material. Then the staging, then the stages in structural assessment, which was discussed, was something new. Like pre-inspection is there, then planning, visual inspection, field and lab test. He spoke about. Then the types of cracks, there was an elaborate discussion. Probably that one slide itself will need a 1 hour discussion. Is about before hardening cracks, like what is a plastic settlement, shrinkage cracks. Then after hardening, what are the types of cracks, structural cracks. Then moving ahead, he discussed, he touched upon NDT part. Okay, so that is also a very deep area to be discussed. Probably we can have a separate session with Mr. Bhavik on NDT part itself. Then he discussed on the design repair methodology, like compatibility of the materials, like acrylic based to be used or epoxy based to be used. Then systematic repair approach he discussed, which was something new. People are doing, but like everyone is not doing. Then the Then he discussed on the CSP, that is concrete surface. That was something new, like what is that characteristic of the surface. He showed some slide where there were 10 categories of the surfaces, and as per that, some chemicals are to be chosen. Then he showed in one nutshell one schematic graph about the repair and maintenance in along the service life, that you construct a new structure and how it dilapidates over the year, and then you repair and again it rebuilds. So that he showed. Then at the end, he showed about two case studies of CPWD. One was where the graniting of the beams and columns were done, and second, which was very interesting, was on the fire damage, where the roof, some portion went up to 1100 degree centigrade of a temperature, and how it was rectified, retrofitted. So on behalf of ISSE student chapter, I thank you, Mr. Bhavik Dhami, and I thank all the participants of the today's webinar. So we wrap up the session, but if at all you happen to have some queries, then please feel free to ask in the chat box. We will send it. We'll compile and send it to Mr. Bhavik Dhami for answering later on also. And the complete recording of this session will be available on YouTube. So please, those who missed it, please go back to YouTube, and you can have one more look. So thank you, Mr. Bhavik. So I announce a closure of this session today. Thank you.
Thank you, everyone.
Thank you so much, sir.
Yeah. Have a good day. Bye.
Good day,
Bye.
everyone. Bye.